Hi, I'm Chen Youxiang. I'm going to present our final project, New Intent Discovery with LLM in Context Learning. In real-world dialogue systems, like chatbots and voice assistants, we usually define a fixed set of user intents in advance. However, these predefined intents often fail to capture all user needs, as new scenarios appear over time. That's why New Intent Discovery, or NID, becomes a crucial task. It focuses on identifying unknown intent for ongoing user conversation, especially in large-scale systems where retraining model every time is not scalable or efficient. Traditionally, NID is done by first learning semantic representations of user utterances, language embeddings or contextual embeddings, and then applying clustering to group similar ones together. More recent approaches like NTP and NTBC LLM combine pre-trained language models with contrastive learning to improve clustering performance. These methods have achieved good results, but they still rely on heavy training and carefully designed loss functions, which can be resource-intensive and less flexible. In contrast, our work explores a more efficient approach. We use large language models, or LLMs, in an in-context learning setting. That means we don't fine-tune the model or train it at all. Instead, we simply provide a few examples inside the prompt, and then the model reasons based on that. We leverage the strong reasoning and generalization abilities of LLM by GPT and allows us to perform intent discovery on the fly, with no extra training required. And as shown in our results, the simple prompt-based method achieve competitive performance, comparable to NTP and the NPPC LLM across metrics like NMI, ARI, and ACC. In particular, we see strong performance at multi-turn Chinese dialogue, while showing that LLMs have great potential for new intent discovery.
Now I will move on to the part of problem statement, the core challenge of new intent discovery. While traditional intent classification assumes all possible user intents are known during training, real-world dialogue systems often encounter utterance expressing unseen intent. This brings three main challenges. 1. Detecting unknown intent. Identifying utterance that don't match any known intent. 2. Clustering the unknowns. Grouping this utterance so that each cluster represents a potential new intent. 3. Minimal supervision and scalability. Since new intents lack annotated data, the system must work in low supervision settings and scale as new data appears. Let's move on to the overview of our approach. To tackle these challenges, we designed a three-stage framework as shown in the figure. Stage 1. Task familiarization with known intent. We begin by using a training set with only known intent. To help the LLM become familiar with the task, we construct few-shot prompts using evaluation samples, then batch 100 utterances at a time for classification. Stage 2. Identifying known vs unknown intent. Next, we move to the test set containing both known and unknown intent. Leveraging the LLM's ability with the task, we again use few-shot prompts. If an utterance is recognized as a known intent, we assign it accordingly. Otherwise, we classify it as others representing unknown intent. Stage 3. Clustering the unknowns via LLM. Finally, we take all utterances predicted as others and instruct the LLM to cluster them into up to k groups, while k equals the number of all intent minus the number of known intent. This clustering aims to discover distinct new intent categories. And here is the result analysis. We benchmark our method on Banking 77 and CSDS, comparing against both traditional and state-of-the-art baselines. Unsupervised clustering using glove or bird-based embeddings, and a strong contrastive learning baseline using MTP CONN, and our own LLM-based context learning using Gemini, GPT 4.1 and Grok Beta. Results show that on Banking 77, our method performs comparably to MTP, but slightly below NTP CLNN and clustering-based method. However, on CSDS, a multi-turn Chinese dialogue dataset, our method outperforms all others by a large margin. We believe this is because in context learning, better utilize the semantic and dialogic understanding of LLMs, making it particularly effective for discovering complex conversational intent. Here's the result of the experiment.
Good afternoon, everyone. In this part of the presentation, I will walk you through the result analysis and summarize the key conclusion of our study on new intent discovery using in-context learning with large language models. Let's begin with the results. We evaluate our proposed method on two benchmark datasets, Banking 77, which is an English single-turn dataset, and CSDS, a Chinese multi-turn dialogue dataset. We compared our approach to several existing methods, including bird-based models like MTP and NTP-CNN, as well as recent LLM embedding plus clustering techniques. On the Banking 77 dataset, our in-context learning approach achieved performance comparable to MTP, even though we didn't perform any model fine-tuning. However, we do note that MTP, CNN, and some clustering-based LLM methods still outperform us slightly in this domain. This more impressive result came from the CSDS dataset. Here, our method significantly outperformed previous approaches, including both contrastive learning models and clustering-based LLMs. This highlights one of our key findings, that large language models, especially under in-context learning, are highly effective at processing longer, more complex, multi-turn conversation. They are able to leverage semantic reasoning more effectively than traditional embedding-based clustering methods. Now, moving on to the conclusion. This study demonstrates that in-context learning with LLMs is a promising and cost-efficient alternative for the new intent discovery task. Our approach requires no additional training or fine-tuning, making it suitable for real-world application, particularly in zero-shot or few-shot scenarios. Moreover, the strong performance on the imbalanced CSDS dataset suggests that our method is stable across challenging conditions. This robustness is especially important for practical deployment in real dialogue systems. However, we also recognize a limitation. While we can group unknown intent samples effectively, our current system does not generate human-readable intent labels during clustering. Bridging this gap will be a crucial step toward building a fully automated NID pipeline. In summary, our work highlights the power of prompt engineering and in-context reasoning for intent discovery, especially in multilingual and multi-turn dialogue settings. Thank you.